In this video, we are going to learn how to rationalize radicals. Why we want to rationalize radicals? Because we want to find the slope of tangent and slope of secant. When we are finding the slope of tangent, which is the limit of the slope of a secant, sometimes we need to deal with radical numbers or radical expressions. So that's the reason we want to see how we can rationalize radicals before we solve for the slope of tangent. Last time we have done finding the slope of secant and slope of tangent with at point P with a number. Now we are going to use a parameter x equals a. Then for the function y equals f at x equals a, the output will be plug in a value is f at a. So this is our first point. And another point, we just pick another point that is plus h. So from a plus h. And h could be 1, could be 0.1, could be 0.001. We want h to approaches 0, then the point Q will get closer to point P, then we are able to find the slope of the tangent. That is a red line. The tangent line is a line that touches the graph at exactly one point. So not intersect at that graph at one point, touches, okay? If intersect, we could draw a random line, but touches, it means it's get closer to that point, then that line, we call it tangent. So now we have x1, y1, x2, y2. We are able to find the slope of the secant. Secant line is connect the 2 points that intersect on the curve. So this is a blue line is a secant, and the slope of the secant is a rise over run. So it's difference of y take away divide by the difference of x. So rise over run. And for the function notation, the x2 or y2 is subbing the a plus h. So f at a plus h. Take away f at a, and x2 is a plus h, and x1 is a. We could simplify the denominator, then we are going to have f at a plus h minus f at a, then a plus h minus a minus a cancel out, we have h left. So this is slope of secant. Then we know that the slope of tangent is when h approaches 0, the limit. So we are going to introduce the limit symbol. So lim represent limit, and we put h approaches 0. Then we put this slope of secant after the limit. Then we are going to have f a plus h minus f at a over h. This is our instantaneous rate of change or slope of tangent at point P formula. And in order to find the limit of this one, sometimes we need to deal with a function that is a radical function. So for example, f at x equals square root x. Then the numerator a plus a, f at a plus h, we plug in a plus h, you will have square root a plus h. Then minus square root, plug in a, we have square root a over h. In order to find the limit of this one, we want to use rationalized radicals to rationalize the numerator, then we are able to cancel the h out. Then once the denominator not 0, we could find the limit. So The next lesson we are going to focus on finding the limits. So, this lesson we are going to prepare for finding the limits. We are going to learn how to rationalize radicals. In order to find the exact value for the slope of tangent, we use a limit, and in order to solve the limit, it requires a knowledge of a lot of simplifying techniques. So for example, factoring, rationalizing radicals. So this is where we want to do in this lesson. So rationalizing radicals use conjugate. Conjugate means if we have two terms, a plus b, then the conjugate is a minus b. So a minus b conjugate term is a plus b. A plus b conjugate term is a minus b. So two terms, numerical term number are same, but sum operation will be opposite. Now we are going to use example 1 and see how we are going to simplify radical expressions. You see simplify radical expressions, there are two things you need to pay attention. One is the radical sign. Under radical sign, the number we call it radicand, and simplify means there's no perfect square number under the radical sign, no perfect square number for the radicand. And the second one, there's no like terms. What like terms means for radicals? It means you have the same radical sign, then the number, the radicand, they are same. Then we call them like terms. So simplify the first one, square root 25. We know 25 equals 5 times 5. So we use this factor tree. So 25, there's no prime number 2, 3 divisible. Then the next prime number is 5. So 25 divided by 5 give you 5. Then 25 equals 5 squared. So square root 5 squared. Squared and the square root cancel out. We have 5 left. So square root and squared, they are inverse operation. So 54, we need to find the perfect square number in 54. We try to use a smallest prime number, then use that one, do the division to find another factor of 54. So 54, the smallest prime number is 2, is even number. So 54 divided by 2 give you 27. Then this is not an even number, so no prime number 2. Then we try the next prime number, smallest prime number is 3. 27 divided by 3 give you 9. Not even number, so no 2. Then we try 3 again. 9 divided by 3 give you 3. The factor tree, the end of each branch, they are the factors of the number that we are doing the factoring. So 54 equals 2 times 3 times 3 times 3. So 2 times 3 times 3 times 3 equals 54. This is fully factored. And for the simplifying of the radicals, we are looking for the number repeat. So 3 times 3, it means 3 squared. This is what we call a perfect square number. So we are going to write it as, we put the perfect square number at front. So 3 squared, and the number left is 2 times 3 is 6. Then we do the same thing, the perfect square number, square root cancel out. We have the number left. So 3 squared square root give you 3. Then 6 left under the radicals. So radical sign is 3 times square root 6 is for the simplified radical expression for square root 54. Then we do the same thing to 5 square root 28. We want to use a factor tree to find the factors of 28. we start from the smallest prime number. This is even number, so could be divided by 2. 28 divided by 2 is 14. Then based on this factor, we continue. So 14 even number could be divided by 2. So 14 divided by 2 is 7. Then it means 28 equals 2 times 2 times 7. And 2 times 2 is same number repeat is 2 squared. So this one 28 equals 2 squared times 7. Then squared square root, we can take it out, so we have 2, then square root 7. 5 times 2 is 10, so 10 square root 7. This is simplified radical sign. And you don't have to show me all these steps. As long as you know 28 is 4 times 7, and you could write it another way. So 28 is 4 times 7, then square root 4 is 2, 2 times 5 is 10. You could just write 2 steps, then it's done. You don't have to write all the 3 steps. So I don't mind which form you are going to use. I want to see that the final answer 10 square root 7 both correct. And please show the middle step, at least one middle step. And square root, the next one is 2 terms times, not only one radical number. So 2 terms, 2 radicals times. We have 3 rules you could follow for simplifying radical expressions. The first one is adding the sum, or you could apply it to subtract. So square root a plus square root a, the radicals, the same radical sign, and the radicand, they are the same. Radicand same, we call them like terms. So when you add or subtract the same radical sign, same radicand, like terms, you just add or subtract the number at front. So 1 plus 1, there's no numbers, means 1, 1 plus 1 is 2. So this is the first rule. And the second rule is 2 radicals times. The radical sign, both of them no numbers, means square root is 2 there. So this one's no numbers means you have a 2 index number there, so it's 2. Second root. Square root a times square root b, we could keep the square root, then the radicand times. If division, then just radicand divide. So for square root 7 times square root 11, we are going to keep the radical sign and just the radicand times. So we are going to have square root 77. And for the 77, we don't have any perfect square number for 77, so this is your final answer. And for the second one, 2 terms times 2 terms, the number at front times. Then the number under the square root times. So we will have negative 3 times 4, then square root 6 times 8. Then negative 3 times 4 give you negative 12. Square root 6 times 8 give you 48. Then we do the same factor tree. You will have so I have the factor tree here. Then all the 2 times 2 times 2 times 2 times 3 is fully factor for 48. Then we count. 2 times 2 is 2 squared. 2 times 2 is 2 squared. You have 2 perfect square number here. Then we are going to write it as negative 12 square root 2 squared times 2 squared times 3. Squared square root cancel each other. Then we have negative 12. Take the 2 out. Then only 3 left. We times all those numbers at front of the radical sign together. We have negative 48. Then square root 3. This is done. So question F, 3 radicals times together, so all the numbers at front of the radical sign times no numbers means 1. So we have 5 times 4 times 1. You don't have to write 1 there. I just want to show you that no numbers is 1. Then the numbers under the radicals, all the radicals times together. Then we have 5 times 4 give you 20 times 1 is 20. Then here 2 times 3 times 30. If you are very good at multiplication table, you know 30 is 6 times 5. So 2 times 3 is 6. So 6 times 6 times 5, we have 6 squared times 5. Then squared, square root cancel out. We have 20 times 6, then square root 5. We have 120 square root 5. So it's simplified. So you have one number and one radicals, one radicand. This is simplified, and the radical sign, there's no perfect square numbers, and this is no like terms. So the next one is binomial, two terms. The adding, subtracting sign separate the terms. This one we call one term, one term, one term, no adding, subtracting. So this one we call two terms, or binomials, binomial. So binomial times binomial, we could use for you. So first term in the first bracket times second, each term in the second bracket. So we are going to have 4 square root 3 times 4 square root 3. Then 4 square root 3 times 2. Times 2, 2 times 4 give you 8. So you could have 8 square root 3 for the first term times the second term in the second bracket. Then after that, we are going to do the -1 times each term in the second bracket. So -1 times 4 square root 3, -1 times 4 is -4. Then -1 times 2 is -2. Then we are going to do this one same as question E. The number at front times the radicands times. So 4 times 4 give you 16. Square root 3 times square root 3 give you squared. Cancel out, you have 16 times 3. Give you 48. Then we have the same radicand, same radical sign, so they are the like terms. For like terms, we are going to add or subtract the number at front. So 8 minus 4 give you plus 4. Square roots 3. So 8 minus 4, when adding, subtracting the integers, sign will take the larger number sign. So 8 minus 4, 8 is larger, so it's positive. Plus 4, then minus 2. So 48 plus square root 3, then minus 2. Then 48 minus 2 give you 46. Plus 4 square root 3. So this is done. This is a simplified radical expressions, no like terms, radicand. We don't have any perfect square number there. So this is a simplified radical expressions. Now we are going to try to find the missing value for these three expressions. From this example, you will see what rationalizing radicals looks like. So 60 over 125, the denominator change from 125 to 25. It means divide by 5, we can get 25. Then what happened to the numerator? We need to do the same thing in order to have the equivalent ratio. So 60 divided by 5 give us 12. So this is done. This is equivalent. Then this one, 5, change it to 5 square root 2. It means times square root 2. Then we do the same thing the denominator times square root 2. So square root 2 times square root 2, it will be square root 2 squared. Then we know that squared, square root, they are inverse operations, so inverse function, it will be cancelled out, so we have only the base 2 left. Then this one, how we can change it from 4 square root 5 to 20. So it will be times square root 5, because 4 times square root 5 times square root 5 give you square root 5 squared. It's cancel out, it's 5. So 4 times 5 give you 20. And we do the same thing, 3 times square root 5 give you 3 square root 5. And you will see the last two examples before your denominator has a radical number and your final answer doesn't have. And from both, how to change the denominator from have a radical number to no radical number is times the radical number by itself. So times the radical number part by itself, then we can get rid of this radical sign. This is what we call rationalizing radicals. So this is rationalizing the denominator. Now we are going to see. So there are 3 examples here. The first one is similar with what we did. So 2 over 3 square root 7, we want to rationalize it. We don't want to see the radical signs, radicand, we just times itself. So times square root 7 to both top and the bottom. Then we have 2 square root 7, the denominator is 3 times square root 7, then squared will give you 7. So you will have 2 square root 7 over 21. Congratulations, you just finished the first rationalizing the radical number denominator. Okay, and the second one is tricky. The denominator is not one term, it's monomial, and this is where we are going to use a conjugate. So what conjugate means? Conjugate is for binomial, you have 2 numbers, before is plus, the conjugate is just change it to minus. And remember, you times the denominator with a conjugate, you need to times the numerator by the same thing. Then they cancel out, you times 1, so you didn't change the value for this expression. Then we are going to times the numerator. 2 times each term is 2 square root 6 minus square root 3, then over. So this conjugate times, what it will give you is, we could use a difference of squares. A plus b times a minus b, you will have a squared minus b squared. So a times a squared, minus ab, then b times each term give you plus ab minus b squared. The middle 2 cancel out, so you have a squared minus b squared. So this is a, this is b. It's square root 6 is a, square root 3 is b. Squared, square root cancel out. So we have 2 square root 6 minus square root 3, then all over 6 minus 3. So you have square root 6 squared is 6, square root 3 squared is 3. Simplify, we have 2 square root 6 minus square root 3 over 3. Then you will see the denominator is a number, is not a radical number anymore. So this is called rationalizing the denominator. Okay, rationalizing the denominator, then there's no radical sign there. So the next one, we are going to do the same thing. So what's a conjugate for the denominator? If you rationalize the denominator, we use a conjugate for the denominator. There are two terms. This is A, this is B. So we have A minus B, then the conjugate is a different sign, A plus B. So square root 3 plus 5 square root 2. Remember, you need to times the same thing to the numerator, then cancel out is 1, so it's equivalent with original expression. Then after that, monomial times binomial, so this times each term. So 2 square root 5 times square root 3, then plus positive times positive is positive, times 5 square root 2. The dot represents multiplication, then all over the denominator is a squared minus b squared. Then this one is radical times radical, number times number, so 2 times 1 is 2, radicand times radicand is 5 times 3 is 15. Then plus 2 times 5 is 10, square root 2, 5 times square root 2 is 10. Then all over square root 3 squared is 3, 5 square root 2 squared give you 5 squared, then square root 2 squared. So this is a multiplication of power, so you apply the 2 to each factor. 5 squared, then square root 2 squared. So you have 25. This one square root 2 times square root 2 give you just cancel the squared is 2. So minus 50. Then simplify. You will have 2 square root 15 plus 10 square root 10 over negative 47. You can just leave the answers here. The hint for rationalize denominator, there are two things you need to know. One is a minus b times a plus b equals a squared minus b squared, the difference of squares. And another one is square root a minus square root b times square root a plus square root b. We use this one. You will have square root a bracket squared minus square root b bracket squared. You have a minus b. Then you will be able to get rid of the radical sign. So this is why we want to use a conjugate term to get rid of the radical sign for denominator. And now we want to try the rationalize the numerator. So read the question carefully. This time is numerator. Numerator means the top. So this one, how to rationalize this one? Just times square root 3 to both top and bottom. Then we want the numerator doesn't have the radical sign. So 6 times square root 3 bracket squared, you will have 6 square root 3. Once you have square root squared, we know we can get rid of the radical sign. And this one, square root 2 times square root 3, this is multiplication of radicals. It's just radicand 2 times 3. Then we have 6 times this square root 3 squared is 3, so 6 times 3 give you 18. Then square root 3 times 6, 2 times 3 is 6. 6, no perfect square number there, so this is a gone. And the numerator doesn't have the radical sign, so this is a rationalized numerator. Okay. And second one, we need to focus on the numerator. So numerators conjugated term, this is minus, this is a minus b, then we need a plus b. So copy the numbers, the two terms here, just flip the sign. Then do the same thing times the same thing to the denominator. Then we are going to expand it. First one is just a squared. Numerator is just a squared minus b squared. Denominator, you are going to have more terms. So 2 square root 6 times each term. So 2 square root 6 first term times each term in the second bracket. Square root 3, okay. Then plus 3 times each term in the second bracket. Plus 3 times square root 3, okay. Then 5 square root 2 bracket squared, 5 squared give you 25. 25 times 2 minus 3 all over 2 times 5 is 10, 2 times 6 is 12, 6 times 3 is 18, 15 square root 2 plus 3 square root 3. Then we have to simplify it. So equals 10 square root 12 give you 2 square root 3. So this one, we are going to use this side to do the rough work. It's 2 square root 3, 18, we have 9 in 8, so square root 9 is 3, 3 square root 2. Then we are going to have 50 minus 3 give you 47 all over 10 times 2 is 20 square root 3 plus 2 times 3 is 6 plus 15 square root 2 plus 3 square root 3. Then we have the like terms for the denominator. We have 47 over 20 plus 3 give you 23 square root 3. They are the like terms. Then 6 plus 15 give you 21 square root 2. Then this is a rationalized numerator. So in this lesson, what we have done is we have practice on simplifying the radicals. If it's one radical number, then we take the perfect square number out. If we have more terms, we collect the like terms. Then we have learned how to rationalize either numerator or denominator. So just if one term for numerator or denominator, you just times the radical sign by itself. If it's two terms, then we times the conjugate. The conjugate is just change the sign. So a minus b times a plus b give you a squared minus b squared. Then square root squared cancel out. Then you have integer left. So thanks for watching.